We've got another theorem we're going to look at here. It has to do with perpendicular lines that we don't really have a good name for, but it's going to be useful to us. So what it says is that if two lines form a linear pair of congruent angles, then they must be perpendicular. Then the lines are perpendicular. All right, so this is another one where you'll see here in a second, our diagram is going to be really important for us because not all these things can really be stored and are given and are proved. So let's go ahead and draw a diagram that kind of depicts the situation. So I have two lines forming a linear pair of congruent angles. Okay, so if I want a linear pair, what I'm going to need is obviously a line that they form, and then they're congruent to each other, which we know just, kind of makes sense that they're going to be at right angles essentially, but we'll have to prove that. So I'm going to label these, of course, call this A, B, and C, and D. Now I'll label both these angles 1 and 2. And so now I can write my givens here. So the two things that are in my given are two lines forming a linear pair of congruent angles. So this linear pair, and this is why the diagram is important, is just going to be taken from the diagram. But the other part says that the angles are congruent, and so what I'm going to start with then is angle 1 is congruent to angle 2. And in my proof, what I'm trying to show is that line AC and line BD will be perpendicular to each other. AC will be perpendicular to BD. Okay, so let's go ahead and start this out, and then we'll think about where we're going with this. So all I have is that angle 1 is congruent to angle 2. This linear pair thing we'll assume from the diagram. So we'll save that for later, but we're obviously going to need it. Okay, so let's think through this. So I'm trying to say that AC and BD are perpendicular to each other. And so the obvious previous step that I'm going to need is to talk about either angle 1 or angle 2 being a right angle, because that's just my definition of what perpendicular is. So the question is how I can get to that. Well, the way that I'm able to show that these are 90-degree angles and that they're right angles is by saying that, well, angle 1 and angle 2, if they're a linear pair, they're supplementary, so they have to add to be 180, but they're also congruent to each other, which if they're congruent and supplementary, the only thing that they can be has to be 90-degree angles. And so we're going to have to combine those two things somehow to get us that, and what we're going to have to do is use some equations here. So we'll go ahead and get started then. Like we said, what I had to start off with is this linear pair thing. So angle 1 and angle 2 are a linear pair. And that is just assumed from the diagram. And then I'm going to now have to start talking about combining these in some way. And so I'm going to have to get to equations. I have to get to some equations I can use. So let's start with the linear pair and try and convert this into an equation that we can work with. The way that we're going to do this is talk about, well, what do we know about linear pairs? We know that they have to create angles that are supplementary to each other. So angle 1 is supplementary to angle 2. How do we know? It's a linear pair postulate that says that if two angles are a linear pair, then they are supplementary. They are supplementary. I'm going to run out of room. Nope. Okay, and where does that come from? That comes from 2. Okay, so now if I want to turn this into an equation, I can do that. So I know that two angles are supplementary, their measures have to add to be 180 degrees. So the measure of angle 1 plus the measure of angle 2 will sum to be 180 degrees. How do I know that? Well, it's my definition of supplementary. Two angles are supplementary if and only if their measures sum to be 180 degrees. sum to 180 degrees. Where does that come from? The previous statement again, so statement 3. All right, so now I need to be able to combine these two things together. My angle 1 and angle 2 being congruent to each other in this equation. So I'm almost there. I can almost do it. But to be able to substitute in here, I need to have another equation to substitute with. And so I actually have to go back and convert this first statement into an equation, because I can't use the substitution property of equality with a congruent statement. So I will do that. I will say that the measure of angle 1 is equal to the measure of angle 2. The reason I know this is just definition of congruence. Two angles are congruent if and only if their measures are equal. Perfect. Okay. So that comes from 1. So now I can actually combine these. And so you can probably see where we're going here, where if I can substitute in, I can get this down to an equation where just one of them will be equal to 90. So I like angle 1 better. Let's substitute angle 1 in for angle 2. And when I do that, I'll have the measure of angle 1 plus the measure of angle 1 is equal to 180 degrees. That is the substitution property. Which I need two things from. I need the thing that I'm substituting into and the things that I'm actually substituting, so 4 and 5. And then I can, and this is a little tedious part of it, I can simplify this to be 2 times the measure of angle 1 equals 180 degrees. This is statement 7, which is just simplification from above. And that comes from 6. So yeah, this is some algebra that we haven't had to do in a while. So statement 8 would be that 2 times the measure of angle 1 over 2 is equal to 180 degrees over 2, which is the division property of equality. This might be one of the first ones I run out of room on. We'll see. It comes from 7. Then I can actually simplify. I can say that the measure of angle 1 is equal to 90 degrees. So that's statement number 9. And that is just simplification from above. Comes from 8. All right, how close am I? Well, let's see. 10 then. So my whole goal and my whole reason of doing this is that to be able to talk about these being perpendicular, I have to have a right angle here. So I can finally say that angle 1 is a right angle using the definition of a right angle. An angle is right if and only if its measure is 90 degrees. Comes from number 9. And so finally I can say statement number 11. Well, what do I know about angle 1 being a right angle? Well, that means that AC has to be perpendicular to BD. Has to be perpendicular to BD. And why is that? Well, that's just my definition of perpendicular. So 2 lines are perpendicular if and only if they form a right angle. That comes from 10. All right, awesome. So just enough room to do all that. And it was kind of a lot, and again, it's pretty tedious, but now I have this thing that I can use to my advantage in future proofs here, where if I just know that 2 angles are both a linear pair and congruent to each other, then the lines that form them will have to be perpendicular. And so this is a nice little fact that we have now about perpendicular lines that we can use in future proofs.